All right, guys, let's go over the last objective, RC5, which is over exponential functions and equations. So anytime we see the standard form for an exponential function, let me get my pen here, which is this equation, y equals a times b to the x, or an equation with x as an exponent. That's important. Then we need to be looking at the table, okay? So right here, remember to look at the graphing table, okay? Now, let's just kind of recap the standard form, this equation, some parts that you need to recognize. So we have y equals the a, and then I'm going to do parentheses, b to the x power, okay? Now, what I want you to know is that the a represents basically the y-intercept. It's also your starting point or your initial amount, okay? It's also your initial amount, especially if we have exponential growth or decay. Now your b, this is your growth factor or your decay factor, okay? It's also considered your multiplier. So this could be a growth or decay factor, okay? And I'll go more specifics on what makes it a growth and decay. We'll see that on the next page. But it's also called your multiplier. Okay. And x is your exponent. Okay, so there are some key attributes to an exponential equation. All right. Sorry. So here's your example. We have f of x equals 2 times 4 to the x power. Okay. To help you see these components, let's go to our calculator. So we're saying whenever you get an equation, anything with y equals or f of x equals, function notation equals, always go to your calculator and type in the equation. So we have 2 parentheses 4, close that parentheses, and we're going to raise it to the power of x. Okay. And what we want to do is we want to look at this graph. Here we go. Well, we can look at the table second graph. All right. And we can see that this is getting big real fast. I'm going to go. All right, we're going to start at 0 here. That's our y-intercept. So when our exponent is 0, that's always going to turn into 1. So we start off with 2. 2 is our initial amount right there. And then it goes to 4, and it just kind of quadruplier kind of a thing. So what I wanted you to see in our graph here, the parts that we need you to make sure you understand, is the part we call an asymptote. Okay. Now, in this example, we're going to look at the graph that we have here on our calculator. The asymptote is where the exponential function kind of flattens out. Now, I'm going to show you on the decimals calculator because I think it's sometimes hard for students to understand that this does not ever touch the x-axis. It's never going to pass it. So if we look here, here's the same function right here. I'm just going to zoom in here and drag. I want you to see something. If I get closer and closer in, this line is getting closer to the x-axis. But if the more I zoom out, it looks like it's further away because it's getting closer and closer, but it's never going to touch it. So when we look at this equation, and just enter this again. Sorry. So when we look at the equation, we're looking at the horizontal asymptote is where this exponential function looks like a horizontal line. I can see it looks like a horizontal line right here at 0. Okay. And so that's our horizontal asymptote. And since we're talking about a horizontal line, the asymptote is horizontal. Okay. And all horizontal lines are y equal a number. And this example for this equation is y equals 0. Okay. Now I can go back to the graph here, and I can see where it touches the y-axis. That's our y-intercept. that was at 2. We saw that in the table as well. So y-intercept is at 0, 2. Now your domain for an exponential function is always our real numbers, especially if we have double arrows, okay? Your range correlates to your asymptote, okay? So what you have to do is you have to look at the asymptote. Here it is. And then look to see, do I have the graph above this horizontal line? Like, is it increasing above? Yes, it is. So if it's above the horizontal asymptote, just like in a parabola, if it's opening up, it's greater than. And if it was below the asymptote, it would be less than. So you just kind of have to remember it could be, your range could be greater than or equal to the horizontal asymptote, or it can be less than or equal to the horizontal asymptote. Since our graph was above, its y is greater than or equal to 0. Our horizontal asymptote was at 0, so that's our range. Okay. Now, here's a graph. They want you to find those same components if I give you the graph of an exponential function. So I can physically see right here. Oops, I meant to do that in a different color. There's my y-intercept. Okay, so that's at 0, 1. My domain is going to be all real numbers. We got double arrows right here. Okay. My asymptote, if I look, it looks like this is an exponential decay going down from left to right. And it looks like it's going to start flattening out right here, which is right there on the x-axis, which is at 0. So this is y equals 0. And my range, my graph is above that. So it's y, the asymptote y is greater than or equal to 0. So you got to remember, extend this page a little bit, when you have a horizontal asymptote, where is it at? It was right here. It's not. It probably isn't. It'll never pass that. Let me show you. I'll get to it. Hold on just a second. All right, this is just a little reminder I had on your notes. This was on your foldable. Okay, little joke here. So if you remember, okay, it never passes line. Use Neverland. Okay, this is an example you should not pass. This is an example of vertical asymptote. Okay, but for exponentials, we're gonna have a horizontal. All right, so now on our next page here, some key components that we need you to understand. And this is where I can explain the difference between an exponential growth versus decay. Okay, we usually use this with interest rate problems or problems that are dealing with a percent. So the form is usually as the following. Okay, and you'll have y equals your initial amount a 1 plus 1 or minus, plus or minus, okay, because plus would be growth, minus would be decay. Your rate, that's your percent as a decimal to the power of t, the time, okay. Now the thing that you need to remember when it's increasing by a percent, b equals 1 plus that percent. So this is where the b would be in our parentheses in the equation that we were looking at before, okay. The b is inside the parentheses. Now when dealing with growth or decay, or understanding how to recognize this value for b, that growth factor, you got to remember that you're changing your percents to a decimal. So anytime I get a percent, to convert it to a decimal, you can just divide it by 100, or right here. And remember, you can move the decimal 2 places to the left. So it was right here between the 3 and the 2, and if I move to the left, now we have that 0 in front, okay. And so when you have growth, like this is an example of growth, this is what the part that you have to remember. The b will always be greater than 1 when you have growth. So in that previous equation, we had 4 was our b, so that's why it was increasing, it was growth. When you have decay, your b is going to be a value between 0 and 1. So if I'm subtracting by 1, it's going to have to be less than 1. So this is up here, depreciation, this example. Our b is 0.92, it's less than 1, but it's greater than 0. That's an example of decay, okay? So again, we have a beginning amount, that's our a, which is always your y-intercept. Your growth or decay factor is your b. Now another way you can get your b, since it's a multiplier, you're looking at the change between, It's your change between y2, the y2 value, over the y1 value. And I can show you that here in a second. Okay, and then your horizontal asymptote, y equals 0, since it never crosses. Now, the asymptote could be at a different place. Okay, just remember, cannot pass it. It'll approach it, but it'll never pass it. All right, so we're looking at this function, and I kind of showed the calculator application here to the side. I just kind of want to hit each part to make sure you have the correct understanding. So remember, your problem here is this scenario here. The population of a city is increasing, so this is growth, at a 4.5%. When the increase began, the population was 1,800. So remember, A is your initial amount, so that is the 1,800. Okay, meaning this is the initial amount, or the starting population. Let me rewrite that. This is the starting population. I'm going to abbreviate population pop. Okay. Now, R is your rate of growth. That is your percent as a decimal. So if I have 4.5%, to change that as decimal, I have to move this decimal 2 places to the left. So that is 0.045. That's what our R equals. Okay. Now, our growth rate factor, remember our B, because we're increasing, this is when we're doing 1 plus the rate. Okay. So we're saying 1 plus that. So this is going to be 1.045. Okay. And our meanings, this is how much it's being multiplied by as it increases. So our equation would be following this little format right here. Y equals the A, which was the 1,800. Then our parentheses, our growth rate, which is 1.045 to the power of t, or I can put x. It doesn't matter. It's the same. Okay. Now they want us to predict the population in 5 years. So here's your calculator help to the side here. So basically, I'm putting the equation in, and then I'm going to my table to find our values. Since they want us to predict the value at 5 years, here's the table. Here's the value at 5 years. Now, I'm not going to put a decimal because we're talking about population. We can't have a tenth of a person. So we're going to round to the nearest whole number. Okay. And then if I look down here, here's the prediction at 10 years. Okay. All right. So what we want you to do or see if you can use your calculator or use your table to come up with the equation or find the missing parts. Okay, so we're going to go to the next page. Hold on just a second. Okay, oh, I forgot to add with the meaning here. Sorry. Before I move on to the next one, I was going to go to the next page. Sorry about that. All right, so on the meaning, this growth factors are multipliers. So it just tells us how much it's multiplying from 1 year to the next. Okay, sorry about that. All right, so on our next page, our last little section, writing an exponential function from a table. Okay, we're going to talk about pencil and paper and then how your calculator can help you to get to this. First, anywhere I see 0, okay, where the y-intercept would be, so that would be right here where x equals 0. Okay, that will indicate our a value. Okay, because remember, this is your initial amount, the starting amount. So this is $1,200. Okay, I'm going to change my font real quick. All right, now to get the B, this is what I was talking about before, the multiplier, the growth rate or depreciation rate it's the ratio between y2 over y1. Okay, so basically this is the first y, this is the second y, and it will work for anyone, but we need the ratio between the two. So we go to our calculator. Let me get out of this, do second quit. and we're just going to do y2, the y value was 1080 over or divided by the first value. Okay, and so I can also do it like a fraction. Let's say you can do the next two. So I could have said 972 over the 1080. It would have still give us the same multiplier. We're showing the fraction. I want to convert that to a decimal. It's the same. Okay, see, it comes out the same. All right, so we know what our B is. All right, so our B is the 0.9. Okay, so they want us to come up with the equation using our A and our B. So our equation here, by equals the 1200 parentheses 0.9 to the x power. Okay. Now, a couple things I want you to remember. Since the B is a growth rate, and actually we could say this is depreciation because it's getting smaller, because our B is less than. This is showing a B 0.9 is less than 1. So this is a decay. And that decay rate, remember, in the form, we have A parentheses 1 minus R to the T. Since I know this 0.9 is what I get when I subtract, okay, to find that rate, I would just pick that 1 or that R. I would just take that 1 minus R equals to 0.9 and solve for R. Well, I'm subtracting the 1 from both sides. I don't know if y'all can just see it. It has to be 10, right? 10%. So this is $1. I mean 1. I know it's minus 1, but it's 0.0. So the difference between 90 and 100 is 10. So if I have a negative R equals a negative 0.10 divided by that negative 1, just, I hope y'all see it. I'm probably just over explaining this, but that is 10.10, which is 10%. Okay, so this is a decay rate of 10%. That's how I get the 0.9. And then this is our starting amount, or the initial amount. Now, to see this on the graph, I have to basically look at the y-intercept, and that happens right here, which is at 0, 10. So initial amount is 10. Now, to get this v, though, okay, I need another point. I see this point right here. That is at 120. And then even if I go to 0.2 right here, that is 240, 2,40. So remember, our B, our multiplier, this is actually increasing growth rate because it's going up, is the difference or the ratio between y2 and y1. So, but when I read this, I got to go left to right. So this, like, let's just talk about my blue points. This is y1, this is y2. So this would end up being 40 over 20, which is just 2. So B is a multiplier of 2. Okay, and you can see that it goes from 10 to 20. If I double 20, that's 40. If I double 40, that goes up to 80. Okay, so now I have my equation. Y equals the 10 parentheses to the x bar. Okay, now you're gonna need your calculator. Let me get that. Hold on just a second. Okay, so if you go to your calculator, and I'm just gonna, because what we're gonna do here on the stat, I'm gonna show you on 36, but I'm gonna also kind of help you how you can check your answer with 34. So I always start off with stat edit, hit enter, and we're gonna clear. I need to clear. You might need to clear too. So just go to the top, clear, and then come down. Highlight the list, hit the clear, and then come down. So let's talk about 34. Let's say if I wanted to check my answers, check my equation. My X column is list 1, so I'm just gonna put 0, enter, 1, enter, 2, enter, and 3, enter. Then I'm going to go to list 2, initial amount 1200, then I went to 1080 and 972, and then 874 and $80. Okay, and 80 cents, excuse me. All right, so then when you would go to stat again to calculate, because we know these are exponential functions, right now we don't see an exponential as an option, but if you see this arrow, you have some more options down here. Okay, so what we're doing is we're going to come down, and right there, 0 is exponential regression. So we're going to hit that, get it to calculate, and there is our A, and there is our B. Okay, so this is a regression, so this is kind of an approximation, and so we should see that we should see some type of verbiage that tells us to do a regression using a model of best fit. Okay, so if I go to our example here that we have down here, we're going to do the same thing. Go to stat, edit. We're going to put 0, 1, 2, 3, and then we're going to have 200, 50, 12.5, 3.125. All right, then we're going to hit stat, calculate. Regression was 0. That's 1, that's 2. And then line of best fit for this one would be the following equation. Y equals 199.2 parentheses is 0.25. And so we're going to record this equation. So just give me a second. Let me write this down. Hold on. All right, so what I wanted to get you, I wrote it down on the other screen, is the graph of this. So just kind of recap, right now we're only seeing one of the points. And if I do zoom stat, which is 9, we should always pick 6, or stat would be for regressions only. We do have a zoom fit if you're trying to make it fit. We'll talk about that later. But really just stick to 6 for standard to reset your graph. But for here, we're going to do zoom stat, which is 9. And now I can see the points. And then if I put in the equation that we just calculated, which was 199.8 to 0. I ran it to 25. So I think it was 4 something. 4.8. So I ran it up into the X power and then hit graph. We can see this regression is going through most of the points. This one's like a little off right here. Now let's talk about a best fit, or just talk about the parts that we can also do by pencil and paper. We know this is our initial amount. This is our A. To get my B, I do Y2 over Y1. So I'm doing B is going to equal 50 over 200, which I can cancel out the zeros. This reduced to 1 over 4. Okay. So my other pencil and paper equation is Y equals the initial amount, which is the 200, times, the B, which is 1/4, raised to the X power. Now, since this B is less than 1, excuse me, again, this is obviously a decay. It's decreasing. And they want us to predict the amount after 6 hours, because this is increasing by an hour each. So if I can either go use this equation I have here, go to second graph to my table, look at 6 hours right here, and since we're predicting, we're making an approximation, it's about 0.0486, or I can use this formula that I have here, and just plug in basically the 6 for the x. So on the calculator, get out of the table so I can quit. We'll have 200 parentheses 1/4 and raise that to the 6th power. And got about the same decimal. Okay. So make sure you know those parts that help you problem solve. And the last thing you have here is just, oops, that's not what we need right here. Is just some calculator reminders to reset. Oh, fix this, guys. This should be 712 to reset. Okay, 712, not 713. Each town? No, okay. This is anytime you get some crazy numbers when you're taking the test and you're like, this doesn't look right. Just reset your calculator and then start over, okay? Remember Zoom 6, Z-Stick 6, standard window, 10 by 10. This helps you determine, if you look down here, use the graphs to help you determine your window. Minimum going to the left, okay? On the X, max is to the right. For the Y max, that's going up. Y min is going down. So you want to look at the tables in your table to help you adjust your window. So like for example, if I put this equation in the calculator, get your calculator, let me get mine. And I go to y equals, first thing, I'm going to do it and see if we have the error, and I can show you why. 16x squared plus 64x plus 80. And then we're going to delete this stuff. Sorry. Make sure I have that right. Okay. So if I go to graphing, oh, it showed it. If there was an error, what it came up, it's probably because I got the stat plot on. It's probably because the plot is on. I don't want, if you look, I still have those points. I don't want to see those points. Okay. So just go up, highlight it, then it'll turn it off. And then we're going to graph. And so we kind of see the graph. We're not seeing all of where it ends over here. Now, remember, if you have Zoom 6, that's a standard. Now I can't even see how high the graph is. I can see the beginning and end. So it's right here is a -1, 1, 2, 3, 4, 5 is my x. So, I don't need to be all the way over 10, but I'm not seeing the height. So this is what I'm saying. You might want to look at your table. So if you look at your table of values, I know, see right here, it starts at 0, ends at 0. I want to look in between, see this pattern. Look for that largest number, that 144. So I'm just going to round that number up because this is kind of around where the vertex is going to be. I'm going to round, that's your y values. I'm going to go up to like 150. So go to your window. I don't need negatives. I just maybe a -5 because I know a -1 is one of my zeros. The max I need is, we can keep that 10. I don't necessarily, I can do that in -5 too. I don't need that. But my y max has to be at least 150. Okay. And the reason why is we have to look at the table here. Remember, we see that right there. And then we go to our graph. Now we see it. Okay. So use your table to help you see things a little bit better when you're graphing. Okay. All right, now the other calculate trick real quick here. Let's say you forget, you're not too sure about your algebra skills when solving. Okay, normally when we solve an equation, pencil paper, we have to distribute. Okay, and then we have to combine like terms if there are. So let's say you're like, sometimes I mess up with my signs. I'm not too sure about this. There is a way you can use your calculator to get the answer. And the way you have to do that is you have to remember this little fact. Okay, you have an equal sign right here. What you do is you make the left side of the equal sign y1. Okay, and the right side of the equal sign y2. Meaning you're putting right here, look, here's your steps. You're putting that in the calculator. Then you might have to adjust your window. Okay, because just like we were talking about before, if I don't see the intersection, then I can't get to my solution. But what you're going to do is you're going to use second trace right here. Choose 5 and hit enter 3 times and identify the x value. That is your solution because you're solving for x. So that's another way you can use the calculator to solve equations. Don't forget stat list. That was the last thing we just kind of talked about. And don't forget to use your table to look for your answers on your table. All right, that's it. Thanks, guys.